So here you can see that, so here's ONOS core, and there are several interfaces implemented in the ONOS core, like the device service and the link service or host service, and we have several, a lot of services that's been implemented for core. And the gRPC resides just on top of this ONOS native service, and we implemented each gRPC service for one ONOS service. So it is almost like one-to-one mapping. And then all these gRPC service can be registered in one gigantic register, then it can be served to the client side. And the third part what I want to mention is it provides higher performance compared to the regular and existing REST API. So if you can see this chart, so this is a ping pong benchmark over. So this benchmark has been provided by Google. So if you take this, here is a REST array, and here's we have gRPC. So this REST, if you are using the REST to test, to run some tests, then it's going to consume 12 seconds. So this is really heavy workload. And then if we are using this gRPC, then it's going to reduce the time almost one fix. So it just provides a very a high performance efficiency, and it uses several techniques to realize this thing. So then I also want to mention that how this gRPC, how we can use this gRPC to communicate this ONOS and external application. So gRPC communicates the external application via HTTP2 connection. So now REST API is all just implemented over HTTP 1.1, and that doesn't support asynchronous transmissions and so on. So it's just blocking all the links and connections and so on. So in terms of performance-wise, it's really cool. But gRPC tried to resolve that issue by using the HTTP2. And also, the serialized message format are extremely compact. As I mentioned, it's an all binary format. Although it's a little bit difficult to debug that, yeah, it's in transmission-wise, it's very efficient. And then the connections are multiplexed and avoid the blocking. So this is what I explained. And then by compiling this provided gRPC model, then it's an all-platform developer can produce stuff in their supported a language of choices. So we can choose whatever languages as you want, and then the stuff provide very basic functionality to sending requests to and receiving requests from ONOS gRPC Northbound in this case. So it's very straightforward for this case, and then there are several connection variants and use cases. So for one call, one response, this is very basic use case. So for example, this external application just call this ONOS one time, and the ONOS just give a response to the external application one, and that's it. So there can be only two types of messages in this case. One is an initial message, and the second one is a closing message. There are going to be no intermediate messaging in this case. And it's very easily implemented synchronously or asynchronously. And also, second type of the communication would be one call, many response. So for example, external application just call one, give some request to the ONOS, and ONOS will send several, for example, response to the external application. So it used for transmission for large, the size of data set. So the client try to initiate an exchange and receive a series of relative, a very small chunk response until the requested data being transmitted over. And this use case, for example, when we want to transfer, for example, a gigantic large topology information from ONOS to external application, this type of transmission will be very efficient. And even if we lose some sort of data, still the ONOS can retransmit that part, so that in terms of transmission-wise, it's very efficient. And also, there could be third use case, which is many calls and many responses. So it's very similar. So ONOS gonna, so the client-side application gonna initiate the certain messages, then ONOS gonna respond immediately, and then based on this responded message, external application can send another request and so on. So there may be some dependencies between the messages, but we somehow have such use cases maybe later on. But now we don't have such use case, but maybe later on we can leverage this type of mechanism. Okay, so the goal, I I would like to briefly introduce the goal of the gRPC brigade. So we like to offering an off-platform application, the performance, application performance, and the granularity of control. So this type of granularity of control and the performance was only available to local or AKA on-platform application. So in on-platform application, you can directly invoke the native Java API and call the service, invoke the service, and use that service. But if you want to provide a similar like a performance and the granularity to the off-platform application, it was pretty hard. But by using gRPC, we can resolve all the issues, and also language compatibility, and also we would like to moving some functionality to the off-platform off-platform. So, for example, so we don't want to run some very heavy calculations and the things in ONOS. So in that case, we can offload that part to the client side, and then client to to do some calculation and then return the result back to the ONOS. And so this will be another interesting use cases that we can do maybe later on. And the benefit. So in terms of so I categorize it as 4 types. So first one is speed. So it dynamically increases the message like a throughput when just compared to the system like the REST and I providing support for multiplex like connections in this case. So the speed is very fast. The size, what I mentioned several times, since it use the binary format, so to encode whole like messages. So the size, the packet size that it should be transmitted from client to server or server to client will be reduced a lot. And then efficient like the content dependent encoding and so on. So if you're using like old technology like XML, then the XML tag itself will it consumes a lot of like the bandwidth, right? So the data, so XML tag it is nothing but just tagging. So it's really inefficient to use it one to transmit. And if you're take a look into this protobuf like encoded like data, it does use a very like small like size of like a binary data just to transmit it. So in terms of simplicity, the protobuf model are reusable across the languages. So once you define a certain model, and then based on this model, depending on what kind of compiler you are using, you can generate several types of like artifacts. For example, if you're using C compiler, then it's gonna generate the C code that works with this gRPC server and client. So you just define one model, and it can be used for multiple like languages and so on. And also, it can minimize the effort of platform developer when write a new like an off-platform application. So the off-platform application developer just need to just reuse the definition and the model, and to just generate their artifacts, and based on the artifacts and the API that the artifacts expose, he can just easily implement the client-side application. And for compatibility, it's really like effortless between the cluster running the different versions of. So actually, gRPC itself also support, maybe to be more specifically, protobuf itself support the backbone compatibility. So if you are running, for example, the ONOS 1.7, and you suddenly want to upgrade that to 1.8. In that case, generally it's a little bit difficult to deal with that, because most of East and West communication, like message exchange to different like types of or versions of ONOS are more or less different, because in each like a different version, ONOS somehow need to change the core API a little bit. So based on because of such changes, the messages that being exchanged between 2 different versions of ONOS will be slightly different. So, but if you're using gRPC to deal with all the East-West communication, then somehow you can deal with such a compatibility easily. And then I would like to explain the contribution what we did so far. So the first step, what we realized by now is like we make a bug build for gRPC. So this was contributed by the Aaron, and so basically we just added a applet for gRPC. So previously we were using the Maven to build whole gRPC artifacts, and that works well. But the thing is, like ONOS, I don't remember the exact version number, but maybe from 1.8 or maybe 1.9, ONOS started to use this bug to build entire like ONOS code base, because the bug can provide faster speed, and also we can leverage a bug. So if you use bug, then you can build the whole ONOS code base in parallel. Using multi-thread, but Maven only support maybe one thread to build the entire thing. So if you're using Maven to build the entire ONOS, it's gonna take like 10 to maybe over 10 minutes. But if you're using bug, then you can leverage multi-thread as well as cache, so the speed is faster. So we try to leverage such a thing, so we added this buglet. And also in terms of model, it's we already created standard, create a standard the document, because it's a brigade effort, right? So somehow the developers should align with a certain, the same region and the code convention. So in order to align that, we added this document, so all the developers and brigade members just read through whole a document and start to contribute to the code. And we also converted a significant set of ONOS internal object model into protobuf model already. So by far, we almost put maybe over 50 the ONOS internal model into the protobuf model. So this is the very initial start of the work, and also the building blocks are ready for who wants to develop their own gRPC services. So there are several gRPC services that we need to implement, but before we implement this gRPC service, somehow we need to define this gRPC model and the protobuf model and so on. So if you want to implement a certain gRPC service, but then rely on a certain model, then first step what you need to do is you need to implement this protobuf model and so on. But yeah, we did a lot of work and to convert that, so it is a lot of work for you guys. And also for translation. So when you implement this gRPC service, somehow you need to translate this protobuf model into ONOS model and vice versa. And this job is very tedious. So we decided to provide a translation a utility which can convert this two models interchangeably. And also we provide so this utility has been given, so you can maybe just use this what we provided. And also we have a starter services. So if you want to contribute your code in this gRPC area, first of all you can join. So one way is you can just join gRPC brigade, or if you just want to contribute some code, then we already created several Jira tickets for gRPC services. You can just take one task and start to code, and the Jira ticket what you provided is a very entry level a task. So I think it's very easy to just take one task and go ahead. And so challenges what we're facing now. So dynamic registration of services. So the problem is when a new service is registered, and then the entire server now is need to be restarted. So we're trying to working on to provide a setup and where the service can be gracefully added and removed without the disturbance, which means without restarting the server, we still can add and remove the service in the runtime. So this should be done maybe later on. And then the second thing what we are facing, the second challenge what we are facing is handling of large data sets. So as I mentioned, for example, the topology information. So if you have very large topology, then they're going to contain very large data sets, right? So it definitely can cause a heavy load. So we plan to we try to split this data set in a small chunk, and gonna send from the server to the client several times. And in that case, we can resolve this issue. And the last challenge what I would like to mention is still data and caching. So the problem is for large data set, the client risks performing the calculation on stale data. So you're trying to find a way to provide a notification to data set, update, allow the client to maintain a local cache, and to reduce the cost of the network. this is a roadmap. So in MagPie release, we plan to add more services. So by far, we added something like maybe services, gRPC services into the ONOS code base, but it's still under the incubation directory. So if that part has been like mature, then we eventually gonna move that like the part to the out from the incubation like the packages. And so from MagPie release, we would like to add more services and the supporting model, and also not so by far we don't have any like a client application, like a demoable client application which like interwork with the server side. So we would like to add one more demo application, including example client code. So we are considering to port this 1P application, and maybe you can use maybe Python language to implement that one. And the registry services, and so this is going to be added in the MagPie. And in end release, we like to add more, and we like to create the registry capable of dynamically updating the set of services and so on. Also, by far, the gRPC service only can provide a certain messages. So, for example, so from the client side, if you want to push a certain like a flow rule, in that case, somehow that should be authenticated, authorized, and audited, and so on, right? But by far, we don't check such permission to things. So maybe in end release, we would like to add that like a part as well. Then we also like to add this stress testing and the performance assessment and so on. So this is acknowledgement. So I really want to thank all the like institution, like the brigade members, gRPC brigade members from various like institution, like GTE. There are 3 engineers that are working for GTE. They contribute a lot of code, and also the previous like gRPC lead Aaron was affiliated the Fujitsu, so special thanks to Fujitsu as well. Then also Frank Wong, I think he might be here. So from ISPER, they also contributed a large amount of code and thing. And also I affiliated OSAG and ON.Lab. So yeah, I just put all the logos here. So if you have any questions, just feel free to ask me. And yeah, and so on. So is there any question? Thank you for your attention.
Thank you, Jean. Does anyone have any questions they want to ask about this new technology that we're adding? Okay, Jean. If I were wanting to implement a new service within ONOS, and I wanted to support the gRPC, I write my code in Java, I get it to work. Now what? Can you give just a brief explanation of how the modeling works and how the translation works?
Okay. If I understand your question correctly, you assume that you added a new like ONOS service, right? So and you want to make a client-side application be connected and interoperable with the new added service, right? So okay, I can go to the slide deck. So here's the basic step. So if you added a new like the services, then you need to go through your service and to find what kind of data model that your service are relying on. And if your service is relying on a certain model, then for the first step is you have to convert. You have to add a protobuf model by looking at existing like the data model. That is the first thing. So somehow you need to edit a protobuf like model first, and you compile that model, then you're gonna get the artifacts. So since we are using Java, right? So the artifacts will be written in Java, and based on this auto-generated artifacts, you can start to implement your service just by invoking this, the API that provided by artifacts. And that's it. So, and then the last step, what you need to do is you need to implement the client-side application. And then maybe if you have time, you can still, you also can write some unit tests and run some tests and so on. That is a general step that we are trying to do. So yeah, it's just straightforward. Protobuf model, and then service, that's it.
All right, well, thank you, Jean.
Okay, thank you. Great.